Mr. Chairman, ladies and gentlemen, my name is Leszek Rolka. I represent the Rzeszów University of Technology. Today, I would like to present the results of our research in the area of multi-criteria decision-making. I will talk about an approach to solving decision-making problems in which a set of subjective criteria is considered that are represented by fuzzy sets. In the process of decision-making, we utilize a fuzzy information system that is obtained in cooperation with experts. We also take into account subjective preference degrees that are provided by a decision maker. The presented method bases on the notion of linguistic label that can be helpful to simplify comparison of alternatives. It can also be conveniently applied in big data environment to preselect a smaller set of the candidate solutions. Let us begin with a formal description of the approach, we use the notion of fuzzy decision system, which is a four-tuple consisting of a non-empty set of elements, in our case alternatives, and every alternative is described by fuzzy attributes or criteria. Every criterion has a corresponding set of linguistic values. There's also an information function that assigns a value in the interval 0, 1. That is the membership degree for all pairs of alternatives and criteria. The number of linguistic values of every fuzzy criterion can be different, so we can define a distinct family of linguistic values for any criterion AI. Every alternative in the information system should be evaluated by an expert who assigns membership degrees in the linguistic values of each fuzzy criterion. This is a very important step because a well-defined and consistent information system should be prepared. And to achieve this, we introduce requirements that can be perceived as generalization of the properties that can be observed in crisp information systems. The following condition should be satisfied when assigning the degree of membership. First, there must be a mostly unique dominant linguistic value, which has a high degree of membership, above 0.5. We also assume that there is at most one neighboring left or right linguistic value. And secondly, the membership degrees for all linguistic values of the selected criterion must sum up to 1. This is an example of a decision table that contains 15 alternatives, and we can see there are 4 criteria, 2 of which have 3 linguistic values, and the second one has 5 linguistic values, and membership degrees of the dominant linguistic values are emphasized by the yellow color. We can check that all the conditions are satisfied for every membership degree. However, because only 2 neighboring linguistic values are activated, and there is a drawback of using a full decision table. This is an inconvenient form of representation because a fuzzy information system, especially in the case of big data where we have a large number of criteria or attributes and many linguistic values, produces a sparse or redundant decision table with many zeros. And to avoid this, we propose to use a compact form of decision table that can be used, which only contains the information about the dominant linguistic values for all criteria. And in every column of the decision table, only one membership degree in the dominant linguistic value of the corresponding fuzzy criterion should be given. We also indicate which neighboring linguistic values are activated. This can be a left neighbor or right neighbor, and it can be easily calculated the membership degree of the neighbor by subtracting the membership degree of the dominant membership function from the sum, which is always equal to 1. A special case with no left or right neighbor is also possible. By applying the formalism, we transform the decision table from our example into a compact form, and this is more suitable for analysis. Now I discuss the crucial notion of the linguistic label utilized in our approach. It was motivated by observation of humans who compare objects of a given universe of discourse. Humans do not perform a detailed comparison of objects to each other. They rather try to assess similarity of a new observed object to an already known prototype. And such a prototype can be described by using a label that is a tuple, a combination of linguistic values of criteria. So instead of using a standard fuzzy similarity relation, which should be selected, and there's a problem how to select a similarity relation, we suggest to apply a linguistic label for constructing classes of similar objects. This is always a matter of membership degree, how we classify objects of a universe. And in order to discover dominant linguistic values, we ought to assume a relatively high degree of membership in the considered fuzzy criterion. And to this end, we use a threshold, similarity threshold beta between 0.5 and 1. And it must be appropriately chosen in an application. And basing on the similarity level, beta, we can divide linguistic values of a criterion and for a given object X from the universe into 3 groups. We have the set of positive linguistic values, having a high degree of membership in the selected linguistic value of a criterion A, the set of boundary linguistic values with membership in between 0.5 and beta, and a set of negative linguistic values that have a small degree of membership. Because the membership degree in the linguistic values of criteria satisfy the requirements that I presented previously, the set of positive, boundary, and negative linguistic values have the following properties, and we can see that there can be at most one positive linguistic value of a selected fuzzy criterion for a given element X of the universe U. To get a complete characteristic of every element of the universe U, it is necessary to combine the positive linguistic values of all criteria. So we define a set of linguistic label, L hat, of X, which is equal to the Cartesian product of the set of positive linguistic values for all criteria. And any linguistic label can be represented by an ordered tuple of positive linguistic values for all criteria. Our goal is to discover elements of the universe that share common linguistic labels. We denote by XL a subset of such elements of the universe that correspond to the same linguistic label L. This way we get a subset of elements which will be called the set of characteristic elements of the linguistic label L. And we return to our example, and after inspecting the decision table, we discover that we have 7 linguistic labels here, and there are 5 similar alternatives which have the same linguistic label L1, and only one object only one alternative has the label L7. Label-based evaluation of alternatives will be divided into 2 stages in our approach. First, at the first stage, we must determine the compatibility of linguistic labels with the preferences for the linguistic values that were given by a decision maker. This way, we can select the best promising linguistic labels which have the alternatives which can be then selected as final solution. At the second stage, we evaluate single alternatives which are characteristic elements of the best linguistic labels selected at the first stage. The decision maker must provide a preference degree, pref of V, for each linguistic value V of all criteria. Then we can express the compatibility of a linguistic label L with the preferences that were given by the decision maker. And this is expressed as a fuzzy set, CL, on the domain of all of the positive linguistic values of the label L. In a multi-criteria decision-making task, the importance of single criteria is influenced by weights that can be adjusted accordingly, and they satisfy a standard requirement of summing up to 1. To determine the compatibility of the linguistic label L with the preferences of the decision maker, we aggregate the preferences degrees using a measure of compatibility, which is also influenced by the importance of all criteria. Here we see the preferences that were used in our example. Because we want to take a closer look at the preferences of a decision maker, we chosen that all criteria are equally important. We have 7 linguistic labels for each of them, corresponding fuzzy compatibility sets are calculated. It can be seen that the linguistic label L2 is the best one because it has the highest possible degree of compatibility with the preferences given by the decision maker. And at the second stage, we perform a detailed evaluation of alternatives that belong to the set of characteristic elements of the preselected best linguistic labels. This is done by applying a measure of weighted compatibility of alternative X with the preferences given for the linguistic values of attributes. And observe that we take into account both the influence of the dominant and the neighboring linguistic values of criteria. This table contains the summary of the results. In our small example, all linguistic labels could be well evaluated and selected for a detailed analysis at the second stage, and the linguistic labels are were ordered according to the compatibility, and their characteristic elements were also ranked. And the final ranking is in accordance with our expectation. That is, the best alternatives are characteristic elements of the best linguistic label. In a real-world application, where we have a large number of alternatives, we can discard the worst linguistic labels and analyze only characteristic elements of the linguistic labels that have a highest compatibility with the preferences given by the decision maker. We conclude that multi-criteria decision making can be performed by applying fuzzy linguistic labels, which are tuples of positive linguistic values of criteria. The presented method is simple, and the result that we obtain can be easily interpreted. In big data environments, we can avoid a detailed evaluation of every alternative in a huge solution space. The problem of multi-criteria optimization is more complex, and this is because we must take into account different kinds of criteria. So in the future work, we plan to extend the proposed method to apply both subjective linguistic and objective numerical criteria at the same time.
We have exceeded the session time a bit, hence I propose to ask questions using the email from publication. Thank you for understanding, and thanks you once again for the presentation.